in the previous lectures we see the that's contain problem. So in the that contains problem we have to remember some points. That points will be, first point is a, always remember there is a exactly one start state in every problem. Only one start state is present. There can be one or many number of a final states are present in that contains problem. So in that contains problem many final states are present but have only one final state. Remember always. And in that contains problem trap state will be occur. In the last lecture that contains problem we tell you the what is a trap state or last state is a trap state. So dead state is a trap state or which is a non-final state. Always remember dead state is a trap state and which is a non-final state. So in the lecture we start with the next type of a problem, that is a odd even problem. Type 4. In the lecture we see odd even problems or odd even numbers of problem. So here we start with odd even number of a problem. So first problem is we have to design DFA where input is valid if it contains odd number of beats over alphabet AB. So we have to find the odd number of a beats over the alphabet AB. So here we start with odd number or even number of a problem. So first part we know theory. So theory, here is the definition of a DFA. So for definition of a DFA, go to my first lecture of a DFA. Next point is a logic behind that problem. So input is here given AB, output will be S no states. So states are, so here is a, we know first state is a QS, that will be a start state, and here we have to find the odd number of a B. So we take state for Q0 for even number of a B, even number of B, and Q1 state for odd number of a B. In even odd problem we take state for even number of a, even number of a B, odd number of a, odd number of a B. In this way we take a state. So we have to here find odd number of a B. That's why we take two states, that are the for one state for even number of a, one state for odd number of a, and that's we have to find odd number of a. That's why this is a final state. Understand? Next point is a implementation. In implementation we draw transition table. So this is our transition table. This is states, inputs AB, QS start state, Q0 and Q1. Q1 is a final state. So Q0 A, here is a contain, and in that even odd problem always remember in Q0 here is a present 0 number of A, 0 number of B. Always remember here is a contain even number. 0 means even. So here is always remember in QS state contain the even number of A and even number of a B, because here present 0. So 0 is an even number. So always remember in QS state 0 number of a present, 0 number of a B present, or always remember in QS even numbers present. So in QS when we take upside A, so here is a contain A which is a even number, which is a even number of a, but so here is a no anything. When we take A from upside A, so here contain a even number of a Q0, here contain even number of a B, here is a container even number of a b, and when we take upside b, so when we take upside b, so here is a present. When we take 1a, so here is a odd number of a b. We have to find b. Here is no any present of a b, that's why here is a 0 number of a b. When we take on, here is a that's it for even number of a b, odd number of a b. So even number of a b, and we take a, so here is the present even number of a b, that's why q0. And when we take b from upside, so even b, suppose I am written here even b, so that's why it is the even b. And we take from upside b, here is even b, and in even b, when we add 1b, so it make a odd. That's why when in even b we add 1b, it make odd. For odd number of a b, we have state q1. Here is a even number of a, it contain odd number of a b, that's why here is the present odd numbers of a b. When we take an odd number of a b and it add 1b, so in odd one add 1b, it make a even. For even number of a b, we have a state q0. So always remember, here is the present even numbers of a or b. So here we have no any b present, so here has a q0 state, because no any means even present, that's why here is a q0 state. For even number of a b, here is a here is a even number of a b present, and when we take b from upside, it make odd, that's why here is a q1. In this way we draw transition table. q0 and q1 have a same state, that's why both are merged with each other. We know merging rule, so we draw the transition table. States input ab, q0, q1, q0, q1, q1, q0. Transition diagram for that problem is, say transition table. q0 is a start state, q1 is a final state. So q0 to q0, a self transition, q0 to q1, b, q1 to q1, b, q1 to q0, b. This is a transition diagram for that problem. In the even odd problem, always remember, in the QS state contain a even number of a numbers, that is a, when we here is a, so even number of a present, and here is a b contain a even number of a b present.